Hello, guys. Just going to talk to you about the periodic table today, just to kind of review it a little bit as well as introduce it, for kind of depending on where you're at in the lesson. But let me go ahead and, yeah, anyway, I'm going to turn the camera so you can see it. I'm going to twist it around, and I'm going to be kind of pointing and moving the mouse around on it. Okay, sorry it's a little bit small for you there, but okay. So this is the periodic table. Periodic table is of the elements. Okay, we talked about last time how everything in the universe is made of matter, and matter is made of atoms. And atoms are those little round ball things that are the smallest piece of everything. So if I cut myself in half a million, billion, gazillion times, I would be a pile of atoms, these little atoms. And every atom might be different. I might have some carbon atoms. I might have some oxygen atoms. I might have some hydrogen atoms. Probably some silicon atoms. I'll probably have different types of atoms, some phosphorus atoms, based on the different parts of my body. So, like, for example, my hair is going to be made of different stuff than my fingernails, and which is different than my skin or the water, right? Everything is made, all these atoms, they're all going to be different, but they all are atoms. They all look kind of like that circular little object, okay? But depending on how that object looks, in fact, let me quickly do a quick search here so I can show you what I'm talking about. Atom. Okay, images. Give me 3 seconds. Okay. All right, here we go. Image, okay. All right, so this is an atom. An atom is basically made out of protons and neutrons, which is the nucleus. This is like that circle thing, okay? At the very center of it, we've got these little protons and neutrons, just this little nucleus made out of stuff. And then around it is these other things. These are called electrons, and they're just floating around and swirling around and around and around. Okay, every atom has these things, but they all have different numbers. So let me go ahead and minimize this so you can see what I'm talking about. So for example, okay, actually, let me go back to that picture. Okay, this one we have three. We're gonna look at the protons. 1, 2, 3, 4, 5. We have 5 protons. Okay, we probably have 2 neutrons in the back as well. We just can't see. 5 protons and 5 electrons. Okay, and 5 neutrons. Just 2 are probably hidden. All right, so we've got the protons. We're gonna look at this one. Let me look at this image here. 5. We want to find the one that has 5. That is actually boron. Okay, if I had a picture of carbon, I would have 6 instead of 5. So I would have, in this picture, I would have 6 blue dots instead of 5, okay? And 6 electrons and 6 neutrons. Okay, if I had nickel, I would have 28 of each one. If I had, I don't know what that one is it borium? I can't read it. I would have 107 of each one, okay? Let's see, cesium, I would have 55 of each one. Every atom is different, and every atom has different amounts. And each atom is this is kind of like a list of the different flavors of atoms. So I've got hydrogen types of atoms, I've got lithium type of atoms, I've got magnesium types of atoms. If I had a pile of atoms on the table, those atoms might all be one type, but likely they're not going to be. They're all going to be different, and each one of them is going to be different based on however many of those circles it has, how many protons it has. Okay, every one of these types of atoms, these are all different types of atoms, every one of them is going to have a different number of protons in it. And because they are different, they're not the same thing. They don't act the same way. For example, silver is different than, gold. Okay, gold is different than silver. Gold is also different than copper. Zinc is different than tellurium. Silicon is different than argon. They're all different because they all have different amounts of neutrons and protons in them. Okay, that's what makes them different. That's why silver is a light gray color and gold is a light yellow color. Okay, that's why hydrogen floats and helium goes up into the sky and makes your voice all weird. Carbon is what your body's mostly made out of. Okay, oxygen is also what your body's made out of, but it's also what you breathe. Okay. Every element is different. based on the number of atoms and stuff in it. Okay, so what they've done, like I said, they've organized it based on however many, and this, it just goes in order. So this number has 1 proton, this has 2 protons, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so forth, 19, 20, 21, 22, and so forth. It just continues to go up and down, or up. This is however many atoms, or protons, sorry, how many protons they have inside. Okay, how many little circles they have. All right. It's a weird shape though, because someone went through and they realized, okay, all of these ones act a certain way. They have like one, they're like, and this is the way they're built. If you look at this picture again, find my picture, notice how there's like a little line, a little shell where these electrons kind of go, and then there's another shell where these electrons go. Sometimes there's more shells, 5 or 6 different shells. That's where all the electrons go, and they all go in the different ones. They don't go in the same one. This first one only lets 2 of them be there. So if you have more than 2 electrons, in this case there's 5, the next shell has to take the more, and then that one can only hold up to 8. So then the next shell takes the rest, kind of thing. If you look back at this image, these ones here tell us how many are on the outside circle. Okay, so they organized it that way. And then also they went through and said, you know what? Every one of these ones happens to act the same way. We're going to call these the noble gases. Okay, every one of these acts the same way. We're going to call them the lanthanides. These ones here are alkali metals. These ones are transition metals. These are metals, right? These are not. Okay, these are gases. They've just organized it in such a way that everything you ever wanted to know about it. If I wanted to know about gold, I could say, oh, look, it's in the transition metals. It must act like a transition metal. Okay, if I wanted to find out about neon, I would go, oh, look, it's in the gases. I know it's a gas. And you could also say it has 10 protons. Okay, I may not know what neon looks like or feels like or sounds like or whatever, but I know that it has 10 protons. I know that it's in the noble gases. And that tells me a lot of things about it. Okay, it tells me it's a gas. It tells me it doesn't react to other things and so forth. Okay, these ones here, they are very highly reactive. That's why they're in this halogen category. Okay, anyway, you don't need to memorize all of these categories, but some of these are like not metals and some of these aren't and so forth. Just understand that this is organized in such a way that helps people understand what type of atom it is. Okay, this top row has 1 shell. Remember I told you the shells? Okay, the shells, this one has 2 shells. This one has 1 shell. This has 2 shells. These ones have 3 shells. These ones have 4 shells, 5 shells, and so forth. Okay, that's generally how this works. All right. If you have any questions, please feel free to message me or ask me during class if you're in person. Otherwise, I'm going to go ahead and close out. I'm going to let you guys move on to the lessons. The lessons will help explain a little bit more. But there's also there is a video coming up that I do want you to watch, and I want you to pay attention to it and fill out the worksheet while you watch it, because that will help explain this even further. It will also explain how they interact with each other. Okay? All right, thank you. Have a wonderful day. I will talk to you guys later. Bye.